I want to talk about question number 19 on the 2020 Pascal contest from Canada. There's two reasons I want to talk about this question. So here are the results for the contest. I've underlined in green the percentage of people who got the correct answer for each question. As you can see, the questions are getting harder and harder. But if you look at question number 19, you can see that there's a big jump from 58% down to 14%. So that in itself I find interesting. It kind of tells me that the question was harder than what the organizers expected. But I also find this number interesting here. So not only did only a few people get the correct answer, but a lot of people got the same incorrect answer. So that kind of tells me that there's a common pitfall that we have to be careful about. So let's look at the question. Each of the following 15 cards has a letter on one side and a positive integer on the other side. What is the minimum number of cards that need to be turned over to check if the following statement is true? If a card has a lowercase letter on one side, then it has an odd integer on the other side. So this is the question exactly as it appeared on the contest. The only difference is I removed the multiple choices. So I'd like you to have a try at that question. I'm going to give you 3 seconds to pause the video, and after that I'll give you a hint on how to solve this question. So pause the video now. 3, 2, 1, moving on. I feel that this question is half logic and half reading comprehension, and I find that adding a more concrete setting to these types of questions can help a lot. So let's look at this slightly modified version of this question. Each of the following 15 cards has a drink on one side and an age on the other side. So you can think of each card as a person in a restaurant, and on one side it tells you what that person is drinking, and on the other side it tells you how old that person is. So now the question, what is the minimum number of cards that need to be turned over to check if the following statement is true? If a card has an alcoholic drink on one side, then it has an age greater than or 19 on the other side. So the reason I chose 19 is because that's the legal drinking age where I'm from. So you can think of that statement as, if a person is drinking alcohol, then they are of legal drinking age. So if you weren't able to solve the original question, try solving this modified version. And even if you were able to solve the original version, try solving it again to see if you end up with the same answer. So again, I'm going to give you 3 seconds to pause the video, and then I'm going to move on with the solution to this problem. So 3, 2, 1, moving on. Okay, so let's solve this problem. So one card is very obvious to check. So if you look at the statement, it says if a card has an alcoholic drink, then the age has to be 19 years old or more. So if we look at the beer here, this is an alcoholic drink, so it's pretty clear that we have to check on the other side to make sure that the age is 19 or bigger. But the other ones aren't that obvious. So let's look at the person who's 32 years old. Do we need to turn the card over? Do we need to know what that person is drinking? In here, it doesn't really matter what that person is drinking. So even if they're drinking alcohol, we know that they're 19 years old or more, so the statement will still be true. And if they're not drinking alcohol, well, our statement is not talking about not drinking alcohol, so the statement doesn't apply. So here, it doesn't really matter what that 32-year-old is drinking, so we don't need to flip the card to check what's behind it. And you can apply the same reasoning to all of the cards that have a number 19 or greater. So we don't need to check the 21-year-old, we don't need to check the 61-year-old, the 42, the 22, the 36, the 76, and the 41. So let's move on to the 13-year-old. Do we need to check what the 13-year-old is drinking? So here we have to check, because if the 13-year-old is drinking alcohol, then that would violate our statement here. We'd have someone who's drinking alcohol and who is not 19 years old or more. So if the person is underage, we have to make sure that they're not drinking alcohol. So we're going to have to check the 13-year-old, and using the same reasoning, we're also going to have to check the 9-year-old. So let's look at the person drinking the glass of milk. Do we need to flip the card over? Do we need to know how old that person is? And here, if we look at the statement carefully, it says if a card has an alcoholic drink on one side, then something. But it doesn't say anything about if the card doesn't have an alcoholic drink. So the statement doesn't apply to this person. So this person could be whatever age they want. So we don't need to check the person drinking the glass of milk. And for the same reason, we don't need to check the person drinking the hot drink, the person drinking the juice box, or the person drinking the bubble tea. So at the end of the day, we need to check everyone who's drinking alcohol and everyone who's underage. So in total, we have to check 3 persons in total. So that's the solution to the modified problem. So whenever you modify a problem, even though it's only small modifications, there's always a chance that you change the solution. So let's solve the original problem together, but using the same reasoning. So again, here if we read the statement, it says if a card has a lowercase letter on one side, then it has an odd integer on the other side. So if we look at the lowercase e, we have to make sure it's an odd integer on the other side. So we're going to have to look at this card. But now if we look at the 17 here, does it matter what's on the other side? Because if it has a lowercase letter on the other side, then we already have an odd integer on this side, so the condition will be true. And if it has an uppercase letter on the other side, then there's no conditions for uppercase letters. So for the 17, we don't need to check it because no matter what's on the other side, the condition is still going to be true. And then for the same reasoning, we don't need to check any other odd integers. So we don't need to check the 57, the 7, the 43, the 31, the 13, nor the 21. So now we can move on. Oh, and we don't need to check the 3 either. So now we can move on to the 60. Do we need to check what's behind the 60? And here again, we have to check what's behind the 60 because if it's a lowercase letter on the other side, then it has to be an odd integer on this side. But we already know that on this side we have an even integer. So if it were a lowercase letter on the other side, our condition would not be true. So we have to make sure that on the other side we have an uppercase letter. So we have to check the 60, and for the same reason, we have to check the 80. And now for the uppercase letters, again, the condition is only for lowercase letters. So if you have an uppercase letter, then it really doesn't matter what's on the other side. So we don't need to look at these cards. And again, we end up with an answer of 3. So this is how you solve this problem. But I'd like to talk a bit more about conditional statements. So in this question, we had a conditional statement, an if-then statement. So here's if you drink alcohol, then you're at least 19 years old. And here I want to give you different ways to think about this statement. So first, I'm going to show you a bit of vocabulary. So the part after the if is called the antecedent. So in this case, the antecedent is drinking alcohol. And then the consequence of the antecedent being true is called the consequent. So here, if you drink alcohol, then it must be the case that you are at least 19 years old. So that part is called the consequent. So now, before we look at different ways of thinking about this statement, let's first think about what this statement means. So even before saying any statements, classical logic tells us that either something is true or its negation is true. So even without saying any statements, we know that either we're drinking alcohol or we're not drinking alcohol, and either we're at least 19 years old or we're not at least 19 years old. So combining these two possibilities gives us 4 possibilities in total, and here I gave an example of each possibility. So let's see what this conditional statement is saying about each possibility. Let's look at the first one, drinking alcohol as a 30-year-old. So you are drinking alcohol, so the conditional statement applies, but you're also 19 years old, so that's fine. So the conditional statement is saying that this possibility is fine. What about drinking alcohol as a 10-year-old? Well, here you're drinking alcohol, so the conditional applies, but you're not at least 19 years old. So this here, the conditional statement is saying that this is not allowed. So what about not drinking alcohol as a 30-year-old? So again, the original statement is only talking about drinking alcohol. If you don't drink alcohol, then the conditional statement does not apply at all. Anything can happen. So here, both the third and the fourth possibilities are all fine according to the conditional statement. So basically, a conditional statement is saying that out of these 4 possibilities, only the second one is not allowed. Okay, so now let's look at ways we can modify conditional statements and see what we get if we do these modifications. So the first modification we can do is we could take the antecedent and put it as the consequent, and take the consequent and put it as the antecedent. So if we flip those over, we get what's called the converse. So if the original statement is if you drink alcohol, you're at least 19 years old, the converse would be if you're at least 19 years old, then you drink alcohol. So these two statements might look similar, but they're fundamentally different. So let's look at what the converse is saying. So we already know what the original statement is saying, but let's see what the converse statement is saying about the four possibilities. So at the very beginning, the converse starts with if you're at least 19 years old. So we know that the condition implied by the converse doesn't apply for people who are less than 19 years old. So the second possibility and the fourth possibility are both fine according to the converse. So already there, we see a difference between the original and the converse. And now, but drinking alcohol as a 30-year-old, we can see that this is allowed by the converse, because if you're 30 years old, well, the condition applies, but you're drinking alcohol, so there's no contradiction. So drinking alcohol as a 30-year-old is also an allowed possibility. But if you look at the third possibility, not drinking alcohol as a 30-year-old, well, in that possibility, you're 30 years old, so the condition applies, but you're not drinking alcohol, so you're contradicting the consequent. So here, the converse is actually saying that it's not allowed to not drink alcohol as a 30 years old. So here you can clearly see that the original statement and the converse statement are saying quite different things. So let's look at another way we can modify a conditional statement. So instead of swapping the antecedent and the consequent, another thing we can do is we can negate the antecedent and negate the consequent. So the negation of drinking alcohol is not drinking alcohol, and the negation of being at least 19 years old is being under 19 years old. So here again, the inverse statement is not the same as the original. I'm going to let you think about that one by yourself. But here, even though we have two negations, they don't cancel out to give us back the original statement. So let's look at another modification we can make. So here, if we take our conditional statement, take the converse, and then inverse the converse, we get what's called the contrapositive. So just to be clear, we take the antecedent, we put it as the consequent and negate it. And here we take the consequent and we put it as the antecedent but negate it as well. And here again, think about it some more if you want to convince yourself, but I'm just going to tell you that even though it's the most different from the original statement and the contrapositive happen to be logically equivalent. So now, why am I telling you this? So if we think back about the contest problem, it wasn't quite clear all the cards we had to check, but knowing that the original statement and the contrapositive are logically equivalent, it makes the contest question a bit more clear. So looking at the original statement, it's clear that we have to look at the cards that have alcohol on them, because we have to make sure that that person is at least 19 years old. And looking at the contrapositive, it's clear that we have to look at the cards that are under 19 years old, because we have to make sure that they don't drink alcohol. So having these two ways to think about a conditional statement can make things a bit more clear. So this is another way to think about a conditional statement, but you're still thinking it in terms of another conditional statement. So I still want to talk to you about another way to think about conditional statements. So again, we saw that the conditional statement is saying that out of these four possibilities, only the second one is not allowed. But instead of saying that as a conditional statement, we can just say that directly. We can just say that drinking alcohol as a 10-year-old is not allowed. And we can do that with an and. So you can say that you can't drink alcohol and be less than 19 years old. So the way we got the and form from the original statement is we took the antecedent and we just copied it as is. We took the consequent and we copied its negation. We put an and in between. And then after that, we just take the negation of all of that. So we're directly saying that out of these four possibilities, the second one is not allowed. And you can try to think about it some more if you want, but the original statement and the and form of the statement are both logically equivalent. Another way of saying that the second possibility is not allowed is by saying that either it's the first possibility, the third possibility, or the fourth possibility. And again, we can just say that directly using an or. So here's the or form of the statement. You don't drink alcohol, or you are at least 19. So the way we got this statement here is that we took the antecedent and we negated it. We took the consequent and we just copied it over as is, and we just put an or in between. So again, we can look at what this statement is saying. Not drinking alcohol means that you're either in the third or fourth possibility. Being at least 19 years old means that you're either in the first or third possibility. So not drinking alcohol or being at least 19 years old means that you're either in the first, third, or fourth possibility, which means that you're not in the second possibility. So the or form of the statement is just another way of saying exactly the same thing. So all three of these statements are logically equivalent. So thinking about the conditional statement in these two other ways can also help you solve the original contest question. So here, if you look at the and form of the conditional statement, it's clear that you have to look at the cards that have alcohol on them, because you have to make sure that the other side is not less than 19. And it's also clear that you have to look at the cards that are less than 19, because you have to make sure that the other side does not have alcohol on it. And if you look at the or form of the conditional statement, it's clear that you don't have to look at the cards that don't have alcohol on them, because those cards already satisfy one of the conditions, and the cards only have to satisfy one of the two conditions. And it's also clear that you don't have to look at the cards that are at least 19 years old, because those cards also satisfy one of the two conditions. Okay, so let's recap. If you have a conditional statement, there are three other ways to think about it. The first way is the contrapositive. To get the contrapositive is you take the antecedent, you put it as the consequent, and then you take its negation. And then you take the consequent, and you put it as its antecedent, and you also take its negation. So if you do all of those things, you get the contrapositive. But you have to be careful. If you just take the converse, it's not the same. And if you just take the inverse, it's not the same. You have to take the converse and the inverse. Another way of saying the same thing as the original conditional statement is the and form. To do that, you take the antecedent, you keep it as is, you take the consequent, you take its negation, you put an and in between, and then you negate everything. So here, when we speak, we don't put parentheses, but I just want to make it clear that the thing you can't do is drinking alcohol and being less than 19 at the same time. So this is not saying that you can't drink alcohol and you can't be less than 19. It's saying that the combination of the two is not allowed. Yeah. And here, another way you can do it is with the or form. Again, you take the antecedent, but this time you negate it. So you take the negation, and then you take the consequent, and this one you keep it as is this time. And then you just put an or in between and you're done. So that's the or form of the conditional statement. So again, these four statements are all equivalent under classical logic. These four statements are all different ways of thinking about the same restriction. And I find that having different ways to think about the same thing is a very, very, very useful skill in math. Math is all about finding patterns and generalities. So if you look at the same thing but from a different angle, maybe different features will pop out. So for example, when we look at the contrapositive, it becomes clear that if the person is under 19-year-old, we have to check if they don't drink alcohol, which might not have been clear if you just looked at the original conditional statement. So that's all I have for you today. I hope you found the question interesting. I hope I was able to shed a bit of light on a potential logical blind spot, and I hope you enjoyed the video. Thanks for watching.